Hi everybody, and welcome to Visualizing Projects in Virtual and Augmented Reality. My name is Dinos Ipiotis, and today I will talk about the benefits of using innovative technologies such as virtual reality, augmented reality, and real-time visualizations in the construction industry. We will see different use cases from different disciplines in which I participated to create solutions for our clients. A little bit about myself. I have been working in the construction industry since 2000. My career in Greece involved CAD drafting, 3D modeling, and graphics. As soon as I reached UK, I got involved in the BIM process within the building services industry. I am also involved in the SIBSI Society of Digital Engineering Group, which is responsible for creating the SIBSI Symbols Library, and also in the project Notre Dame, where a team of experienced professionals decided to reconstruct the iconic structure in a BIM environment after the recent fire. So, to start with, I would like at first to mention the definitions of virtual reality, augmented reality, and real-time visualizations. I believe that most of you are already familiar or have seen a VR headset or an AR application, but I strongly believe it is worth mentioning. Virtual reality is described as a simulated experience that can be similar to or completely different from the real world, and currently standard virtual reality systems use either virtual reality headsets or multi-projected environments to generate realistic images, sounds, and other sensations that stimulate a user's physical presence in a virtual environment. A person using virtual reality equipment is able to look around the artificial world, move around in it, and interact with virtual features or items. Augmented reality can be defined as a system that fulfills three basic features: a combination of real and virtual worlds, real-time interaction, and accurate 3D registration of virtual and real objects. Most commonly, people understand that virtual reality needs a headset such as Oculus Rift, in which you are in a completely virtual environment, and augmented reality requires a handheld device, such as a cell phone or a tablet, in which the 3D elements interact with the real world through sensors and the device's camera. Further to that is the mixed reality, which we will not cover in this session, but just for information, it consists of a wearable device, such as the HoloLens, and the necessary software which projects the 3D elements in the real world through the lenses. On a similar approach to virtual and augmented reality, the real-time visualizations of projects play a significant role in the construction industry. Similar to virtual reality, but without the use of a headset, an individual can navigate around the construction model with a keyboard and mouse, or a gaming controller such as the Xbox controller. The video games industry led the way, and now the AEC industry is picking up. The construction industry is one of the industries which adopt new technologies with a smaller pace compared to other industries. There are several factors which contribute to this slow adoption. From what I have encountered until now, fear of change is one of the biggest factors, and testing something that we are unfamiliar with gets us out of our comfort zone. But once there is proof of concept and a well-structured approach, then we can embrace the benefits of these new technologies. Training also plays a significant part. There is no point in purchasing new software and hardware if people do not get proper training in using the tools. When I started the journey to VR and AR in MLM Group, people were aware of the existence of these tools, but not in our working environment. By performing a step-by-step approach, I was able to create several presentations which contributed to the successful delivery of projects. Also, we realized that what we did was pioneering, and only a handful of companies were doing similar actions to embrace new technologies such as VR and AR. There are a number of positives and negatives on using these new technologies. Let's see some of them. By using virtual and augmented reality tools, we can easily tick a number of boxes to successfully deliver a construction project. A number of factors from different aspects contribute to this. When we are working, for example, in a BIM project, we can easily inspect our information model. There are tools today to provide real-time collaboration environments so that multiple users, with or without their VR headsets, can log in a virtual session and discuss several issues. Some of the benefits of using virtual reality in our daily workflow can be seen in this slide. Collaboration and decision-making. As we can understand, better decision-making reduces risks and costs. Collaboration reduces wasted time, can increase efficiency in information management, can evolve the team to learn from each other, and improves productivity. All parties in design can have a better understanding of the project regardless of their level of experience. Classes can be discussed and resolved. Construction errors can be handled in a virtual environment instead of trying to resolve while on site, which increases costs significantly. Whoever is involved in BIM can fully understand the benefits of the digital twin. Virtual reality can boost this process. Not relevant people, such as clients or sales, can have a better understanding of the design solutions provided. Better information models. There are tools nowadays which transfer the information to the virtual model. People can easily inspect, for example, an air handling unit and see all the specifications in a virtual reality environment. Spatial awareness. It is totally different to see a two-dimensional drawing, a 3D image, and a 3D view in which we can orbit around the model. In a virtual reality environment, we have the sense of depth and perspective. We can understand the mass of a model, how big or small the elements are, the distances kept, the clearance zones, and can easily investigate a model from a health and safety perspective. One of the fundamentals of ISO 19650 is to work in a project having the end in mind. Virtual reality can aid the proof of this concept by presenting the final outcome of our design solution. Last but not least, even though we can discuss several hours about the benefits of VR, is education and training. VR can be used internally within an organization to train employees in several tasks. But, as nothing is perfect in this life, virtual reality has some negative aspects which are worth mentioning, such as expensive equipment for smaller businesses. Although the prices have dropped over the last few years, some businesses may find the investment a bit expensive. Let's not forget that apart from the headset, a terminal must be capable of running VR, and people must be trained to create VR experiences. For simple solutions, there are easy workflows, but the complexity which can be put in a VR project can have some significant impact in time, training, and costs. Motion sickness. As VR tricks our brains in how we pursue what we see, motion sickness is a well-known counter-effect of excessive use of VR. Eye strain. Going further to the impact of wearing a headset for a long time, eye strain is also known as a negative in the use of VR. Still, in order for this to happen, a user must spend some significant time wearing a headset. Portability. Some steps have been made in making the headsets more portable with the use of sophisticated sensors. Still, though, we are far from having a VR headset portable and durable enough. Still, most of the VR experiences are held within an office environment and not, for example, in a construction site. Let's see now the benefits of using augmented reality in a project. Handheld device. People are familiar with their cell phones and tablets, are capable of downloading an application, so this keeps them in their comfort zone when requested to use an augmented reality application. There is no previous experience needed. There are augmented reality applications which simply project the element we need to present just by following simple workflows. For example, open the app, place your phone over the QR code, and voila, your element is on your screen waiting for you to inspect. Non-specific operating system. Developers of augmented reality applications will create their app for both iOS and Android. Bridges knowledge gap. There are people on site which might not be capable of reading a drawing due to inexperience. There are times that the construction detail is not clear in the plan view. These are just two examples of daily issues in the construction industry. Augmented reality bridges the knowledge gap as the 3D element will project in the real world, so this eliminates errors and relevant costs. Training. There are augmented reality applications nowadays which immerse the user in a training environment, and by following a step-by-step process, the user can receive training, for example, in equipment maintenance. Low cost. There is a huge diversity in the costs, usually in a subscription scheme, but for basic tasks such as projecting a model using a QR code, there are cheap solutions out there. But, as already mentioned, nothing is perfect in this life, so let's see some of the negatives that augmented reality has. Small model size. Even though the latest cell phones may have powerful processors, they cannot handle heavy and complex augmented reality models. This gives limitations on the amount of information we want to communicate, and sometimes may require advanced techniques on bridging the model size from the actual software to the augmented reality application in a value capable of being handled by this. This keeps improving though, so I believe soon we will be able to handle large complex models in our devices. Surrounding lighting environment might affect performance. The augmented reality applications use sensors to scan surfaces and place our model. In darker environments, this affects performance. As an alternative, developers add a simple viewer in order to resolve this. Reduced performance in cheaper, older devices. Technology is evolving very quickly, so a device which is a bit old or a device which is cheaper might fall quickly in poor performance. Based on personal experience, devices up to 2 years old with a purchase cost of around £160 are just about to start performing poorly in AR applications. Let's discuss now some use cases of virtual and augmented reality. Some videos will be presented in which I will go through the process and what was achieved. The first video is about a Stage 4 project. This is a fully coordinated plantroom, and this was the first attempt on moving things in the virtual reality environment. Our approach was to create an appealing result so that stakeholders can understand our design solution. Therefore, we used Revit to create the coordinated model. We resolved all classes in Navisworks, and because there weren't any automated processes, we had to import the model in 3D Studio Max for further cleanup. Then the model was imported in Unreal Engine, and we added keyboard controls in order to navigate around, but soon enough we realized that we needed an export controller to give a more gamifying experience. Afterwards, we decided to move into a hybrid solution and produce 2 versions of the same project, one to use on a PC like a first-person shooter game, and another one for an immersive virtual reality experience. All models were downloaded from manufacturers' websites, and the lights are using IES files. We also added small details such as the flow stickers and the schematic in a frame next to the entrance to enhance reality. An understanding of using this new technology soon formed decisions to move forward into different disciplines and test the waters on more complex situations. The second video presents a small step further to what was achieved in the first one. In this use case, a structural model from an energy from waste facility was used. The model was again developed in Revit and then imported in Unreal Engine. No need for further cleanup was needed as the model was not heavy to be handled from Unreal Engine. Due to the mass of the construction, we quickly realized that we needed a jetpack to fly around and inspect the model. Again, 2 different versions were created, one for simple PC use and one for virtual reality. Another benefit we figured out from a health and safety perspective was the fact that we could easily inspect holes and openings in the ground, so contractors could have a better understanding of which areas to avoid once they enter the construction site. We then did some trials on testing in different laptops and desktops to realize the range of good or poor performance in different terminals and better understand on the specifications a terminal needs to run such presentations. The virtual reality experience was really impressive as the user flies around the construction in a sunny day, as you can see. One thing though that really caught our attention was the diversity between users getting motion sickness or not. Other users could not stand even for seconds, while others easily spent some time flying and walking around the model. We used the Oculus Rift for the virtual reality version, which we combined with an Xbox controller for ease of use. The training a user needed was only to familiarize with the controls and how to walk or fly around the model, which was covered in a brief demonstration before wearing the headset. At this point, people from Epic Games, founders of Unreal Engine, had seen the plantroom presented previously and got in touch with me in order to aid in finding ways and solutions to innovate in the AC industry. The discussions resulted in creating a widget while in Unreal Engine to present the metadata a BIM asset contains. I was honored to collaborate with the support team in Epic Games Montreal and develop the widget as you can see in this clip. We experimented using 2 different equipment brought in Unreal Engine using their Unreal Datasmith workflow. This transferred all the metadata the asset contained, and then we developed a widget which a user clicks on an asset and this gathers the information and projects it on screen. Due to the amount of information, a scrollable widget was the best solution in order to keep things tidy. We also made sure that materials and lighting were in a level that the client would be totally impressed. I soon then realized that I had to use materials from the Unreal Engine marketplace, which contains some really good libraries, even for free. Then, the result could be exported in a standalone application and be sent to the relevant party for inspection and review and comments. We were aware that other software could do the same exact thing like Autodesk Live, but I had a completely bespoke solution for our clients' needs. The BIM model with all relevant information was transferred in a real-time environment where the user can walk or fly freely in a model, but most of all, the user could click on the different assets and obtain the information that was developed in the BIM software, which in my case was Revit. The next challenge was to transfer this in a virtual reality environment. That would be the next step on understanding a model from a reality perspective, since the headset gives a sense of depth. I used the Oculus Rift for my virtual reality solutions. By that time, another interesting structural model got in my hands, and again with the aid of Epic Games Montreal Studios, the BIM widget in VR was completed. As you can see in this video, the user teleports to move around the model, points on the desired asset, and the widget appears like a watch on the wrist. By mapping the ability to scroll the values the asset contains within the widget to the Oculus controller's thumbsticks, the user can scroll up or down to see the relevant information. Nowadays, we discuss about digital twins, BIM, and innovative technologies. One of the things that my experience taught me is that there is no limit when we discuss on visualizing projects. The next use case is about a DFMA project. The client needed different parts of the project to be visualized due to the mass and complexity of the project. I was requested to create a combined real-time and virtual reality presentation in order to communicate our design solution. As you can see in this video, 6 different parts of the project are combined in a standalone application. The template used gave me the ability to choose between desktop version or virtual reality. The user then can orbit around the design solution. By clicking on objects, the user can receive the relevant metadata information, and the material selection was based on actual information from the manufacturer. Here, the mechanical and electrical parts are demonstrated with materials. We can see that class detection has been performed and the project is in a stage 4 compliant development. Different rooms, such as bathrooms or utility cupboards, were presented using physically based rendered materials to achieve a photorealistic result in order to impress the client. Focusing on using the right colors and textures to accompany the BIM data information completes the solution provided to the client. The use of complex materials helped us resolve the issue of how to orbit around the model and have the wall we are looking at in a transparent form, but as soon as we are within the bathroom, for example, we could see the tiles. What we achieved is combining the engineering part, which might be difficult for people to understand, with an aesthetic solution, which made things easier. And by providing the asset information in our solution, the client realized the effort and hard work which a project needs to be accomplished. Further to this, the client can even receive information, such as manufacturers' websites, since these are included in the asset information. All products contain metadata information from pipes, radiators and baths, to sockets, lights, ducts, and even showers or walls. The utility cupboard contains all Unistrut information, tri-trap, heat recovery unit, etc. By having the virtual reality solution attached to the desktop version, the client can easily jump into virtual reality to see the mass of the solution, understand heights, spaces, and complexity. In this presentation you can also see the manifold, you can see different electrical equipment, heat recovery units, and the necessary walls, etc. The following use case came literally out of one sheet and was a proof of concept that there is no limit when we discuss on digital twins. In collaboration with our rail team, we decided to challenge ourselves and create a virtual reality presentation of a footbridge proposal for a client. One of the things that amazed us was the difference virtual reality makes in understanding the mass of a project. We started testing the waters of external landscape, vegetation, foliage, and making a natural environment. We could also inspect the slope of the footbridge, since it has wheelchair accessibility, and the result satisfied all parties. We will see also the augmented reality version of this bridge in a bit. The controls involved orbiting and navigating around the model, with scrollable zooming in or out in the desktop version, while teleporting was the best solution in virtual reality to avoid motion sickness. But let's discuss about the workflow to achieve visualizing projects in virtual reality or real-time environments. The initial approach was using Revit for designing the engineering solution and then export to a common file format that Unreal Engine would understand. As we were discussing about 3D models, the next thing we had to think was the polygon reduction. For example, when we exported a pipe with insulation that was translated as a cylinder within a cylinder. This resulted to unnecessary geometry within our model, which simply caused poor performance. 3 years ago, there were some tools to automate the process, but it was still time-consuming. We used 3D Studio Max to enhance our models, reduce the polygon count, and adjust some values such as material glossiness. Then, we imported the FBX file in Unreal Engine and added controls, adjust lighting, materials, textures, and produced a real-time presentation and virtual reality experience. The use of Blueprint visual scripting system was mandatory throughout the process. After a while, Epic Games developed the Datasmith workflow and produced the Datasmith plugin for 3D Studio Max and Revit. That was a game changer, as it would allow us to directly import our scene in Unreal Engine without the hassle of exporting in 3D Studio Max and doing all this time-consuming process. Also, by the use of some tools Epic Games provided in Unreal Engine, we were able to load and unload parts of the scene to increase performance and still have more of our assets kept in the scene. Some other tools handled object visualization based on mass or complexity, increasing the frame rate. We used physically based rendered materials to have a more realistic result, and we also experimented with IES lights to simulate the lighting environment our light calculations produced. After the release of Twinmotion from Epic Games, we started seeing the potential of checking things quickly in a real-time environment. Twinmotion is not a new tool, but it got further enhancements after the company was acquired by Epic Games. The workflow was straight from Revit into Twinmotion. A cropped 3D view, an entire floor, or the entire scene can be loaded within minutes, keeping materials from Revit and then exporting images or video. The rendering lasts from a couple of seconds for an image to minutes for videos, as this is a real-time engine, therefore there is no need for light cache, final gathering, or other traditional rendering time-consuming processes. We have developed our Revit templates with color-coded materials, and we are able now to visualize a project in Twinmotion quickly and effectively. The scene is VR compatible, so we can wear a headset instantly and navigate around the scene. And all these can be exported in a standalone application to be used in a PC. Then we started experimenting a bit more with Twinmotion, as it is capable of importing FBX files. Soon we found colleagues that were performing similar tasks in Northern Europe, and the next example is the ultimate approval of the benefits of visualizing projects in virtual and augmented reality, as it was a cross-border collaboration in a drawingless design project. This is the Randselva bridge in Norway. Since May 2019, MLM Group became part of Sweco. This opened the gates to cross-border collaboration between different countries. Sweco Norway has delivered over 40 projects with a drawingless design approach. This means that all latest tools and technologies are used in order to deliver information from design stage until handover and closeout of a project without having to print a single drawing. And this is where virtual reality, augmented reality and real-time visualizations really play a big part. By using the latest tools such as Twinmotion, we delivered a real-time presentation of the bridge construction, utilizing the 3D landscape extracted from LiDAR and drone footage. We added foliage to accurately represent the surrounding vegetation, and also traffic simulation. Different daylight and weather conditions were utilized. The structural model was imported from Tekla, and we used physically based rendered materials for a more photorealistic approach. The road lights are using IES information, and we add transparency in certain parts to demonstrate the rebars and tendons. We also experimented with panoramic video production for YouTube successfully. This is the first phase of this presentation, as we intend to add acoustic information based on the simulations the acoustic engineers will produce in order to be able to stand in key positions in the area and listen to the actual noise produced by traffic. The Randselva bridge has a lot of information exchanged through the life cycle of the project. To give you two examples, its rebar was scheduled, counted and positioned based on the BIM model, and people in the construction site used augmented reality to place the model in the physical world with the use of a tablet. Secondly, the nuts holding the rails on the roadside contained actual coordinates to be accurately positioned instead of the usual measuring approach found in traditional drawings. I would like to thank Øystein Ulvestad from Sweco Norway for giving me the opportunity to get involved in this project. Now this concludes the virtual reality use cases. I believe that at this point it is accepted that virtual reality and real-time visualizations is an important part of understanding a project. Now let's start looking in some augmented reality use cases over the next videos. But before moving into augmented reality, I would like to talk about the workflow to achieve the desired result. At first, a 3D view must be exported as a common 3D file format. I am a Revit and 3D Studio Max user, therefore was using a 3D view which usually had a section box in Revit, or a direct export from 3D Studio Max as an FBX file. Due to performance limitations, I usually export small scenes, thus the section box in Revit is vital. The next thing to do is upload the FBX file in the application's web interface. Modern augmented reality applications which target to the AEC industry have a web interface to upload the models, make necessary adjustments, and produce the QR code. After the model is uploaded, then the QR code can be extracted in an image format and saved locally. Simply then, the QR code can be placed on the sheet in Revit or provided via email to the client. The QR code is used in the augmented reality application, and once scanned, then the 3D model is projected on the surface. Let's have a look at some examples in the next video. As discussed, the approach in augmented reality was to create a QR code and project the construction detail on top of the drawing sheet. This aided a lot in business meetings for all parties to understand the proposed solution, and for people in construction sites when there was any miscommunication or difficulty on understanding the request. As you can see in this video, several models from different disciplines can be projected in an augmented reality application, and the process was fairly easy, usually by exporting a 3D view from Revit or by creating the 3D model and exporting in a format the augmented reality application understands. The QR code was automatically created and then placed on sheets. The users were scanning the code and then the model was projected. Based on the file format, several different abilities can be added, such as materials or basic animation. This video presents models from different projects, such as a structural model of a ramp, a structural floor, a roof assembly, a water tank room, equipment for an energy center of a large residential project, and the footbridge, which was also presented as a virtual reality use case. The collaboration between different disciplines within the company to achieve this result was vital. Each use case demonstrates a different request from engineers and directors, as there were different needs for its project. Quickly I understood that even the variation of requests could make things a bit difficult. Once the model was projected, the relevant party was able to explain and communicate effectively with the rest of the interested parties. So to say, augmented reality was successfully used to bridge this gap in communicating requests, and the best thing was that the process was so quick that added a relevant small cost to production. While all this is a constantly learning process, we used the lessons learned from our use cases in virtual reality presentations and worked on automation of processes such as material library templates to be used for augmented reality. We used simple material parameters in order to keep things as light as possible. We also tried to create families in Revit which would be not that complex as models when we knew that we would use augmented reality. We tested different devices from phones to tablets and operating systems to compare and learn about the capabilities, pros and cons of each device, and what was the best solution in each case. As you can see, there is no limit on how augmented reality was used. Even not directly connected to a construction project, but related more with marketing purposes, I created an augmented reality business card. The process was to augment the video created from the marketing team, and then I used the image scanning feature in the augmented reality software provided in order to project the promotional video. This adds value in advertising, education and promotion, as we all know these are aspects which should also be considered. So to conclude, visualizing projects in virtual and augmented reality should be a norm in the construction industry. The tools are not as sophisticated as they were a couple of years ago. Software developers have understood the knowledge barriers they need to overcome and have put a tremendous effort on simplifying the process. The future is bright for using these technologies in the construction industry, and it is a matter of us using them. At this point, I would like to thank UKBIMA Alliance for giving me the opportunity to talk about visualizing projects with virtual and augmented reality. You can find the relevant videos also on my and MLM Group's YouTube channels. Please feel free to reach out either via email or send me a connection invitation on LinkedIn. Have a lovely evening and thank you very much for watching.